With the Spark introduction. Last week, what we studied was Scala language that we studied last week that is required for Spark programming. Required for Spark programming. Actually, Spark can be programmed using different languages like Scala, like Java, like Python, and also using R language. R is used for mathematical and analytical purpose. Most of the codes are written in Scala language, more than 50% approx, and maybe 30 or 20% in Java and 30% in Python. R we don't consider because we are not studying into data analytical part. Okay, so Scala we have already learned. How Spark started was initially you were having let's go to Hadoop 1.x version. In Hadoop 1.x, if you remember, there was something called as a HDFS, Hadoop Distributed File System, and there was something called as a MapReduce. So there were these two things, and all the thing resource management was also done by MapReduce part. So the responsibility of resource management was on MapReduce. So what happened was later on it came as Hadoop. It was separated something like this. HDFS. There was something called as a yarn that will be managing the resources, and there could be different applications on top of it like MapReduce, Spark, and other things as well. So this is how it went into Hadoop 2.x. So now we are seeing how exactly this Spark got birth is. Over here, there was something called as a Mesos, MESOS, something called as a Mesos. Mesos was nothing but a resource manager only, a resource negotiator only, something similar to Yarn. So Mesos was a resource negotiator or a resource manager, something similar to Yarn. And to test this resource manager, they were testing this resource manager using MapReduce program. By running MapReduce program, they were testing is the Mesos working fine or not and so on. And they noticed that it is working totally fine. So they decided to test the Mesos application using one more thing that is called as a Spark. So what they did was they developed this Spark programming language to just test something called as a Mesos. So Spark was developed to test Mesos, and it was developed at University of Berkeley in 2009. University of Berkeley in the year 2009. So they developed the entire different programming framework, a different programming itself just to test for Mesos. But what happened is after Mesos, Yarn came and like people preferred Yarn over it and the Mesos just died off. And people stopped using Mesos or they did not prefer Mesos or they never went into, most of the people never went into using Mesos. But what they found was Spark is really a good concept. Like MapReduce, you have to you do all the things in stages. You do perform one activity, then you write into a hard disk, then again you perform some activity, you write into a hard disk, again read and again write and so on. So you're doing read and write so many number of times, hence it was very slow. But in case of Spark, you are not going into hard disk much. It was in memory, and instead of going into hard disk, you are going into RAM. And RAM is more fast. So you're not going much into hard disk. You're just taking the data, processing entirely, and then finally storing. So it was very fast. So they realized that Spark is actually very fast. Though Mesos died off, what we can do is we can try to revive the Spark. And that's how they started working more and more on Spark. So this Spark was developed in University of Berkeley in the year 2009. Then the people who developed this Spark in University of Berkeley, they started their own company called as a Databricks. So Databricks is the company that was formed by the actual people who actually developed the Spark programming language. They developed the Spark programming language using Scala language. Spark code is internally written in Scala. They are entirely written in Scala. So the Spark code or the Spark entire framework is written in Scala, and these people went and formed their own company that is called as a Databricks. Databricks contributes to almost more than 70% of code until now on Spark. So Databricks is the company which is contributing the most to the Spark. Year and on year, more than 70% they are contributing to Spark. However, the Spark is open source under Apache. So Apache is a company which is having an open source license, and the Spark is open source under the company called as Apache. And currently there are this is the Apache Spark, which is a free as well as open source. However, Databricks also has its own version of Spark, not major changes, some minor changes only, and that is like paid one. You have to pay the licensing fee. So basically, there are two categories. One is the free version that is available with Apache Spark, and most of the distributors have it installed or they provide it like Cloudera, Hortonworks, and Mapr. Mapr is again one distributor. Then other things like IBM, Oracle also goes into big data nowadays, but they are not that famous. So these are very famous, and Cloudera is the most, I believe. Hortonworks is second, or Mapr is third. So the Spark, Apache Spark is available in all the major distributions of Hadoop. If you want more on documentation of Spark, I will be sharing the few of the books. However, you can find most of the good documentation on Databricks' own website. So if you go to their own website, you will get lot of documentation about Spark. Also, there is a book called as Spark: The Definitive Guide. It is currently not available for sale in most of the places. Even in Singapore, it is not available, but you can buy a Kindle version of it in Amazon eBooks. It cost around $25 to $30. And this is a good book written by the founder of Spark itself. Name is Metie Zaharia. So this book is written by Metie Zaharia and a few more people. And it is available on Amazon readables. You can buy it for $25 to $30. Hard copy is around $40 plus, but not available. Okay. So this was about brief history of Spark. Now currently, let's go to the next one. Currently, there are two major releases of Spark. One is Spark 1 and one is Spark 2. So whatever is the code of Spark 1 can run definitely on Spark 2. There is lot of process improvements, process performance improvement. But however, most of the companies work on version 1.3, 1.5 or 1.6 of Spark. Most of the companies are either on 1.6 or 1.3 of Spark. The one that we have in our Cloudera version is Cloudera is Spark 1.5, the virtual machine that we have installed till now. It is having a Spark version 1.5 already installed, and we'll be practicing it on 1.5. If you also happen to install Hortonworks, Hortonworks has 1.6. So if you are excited about doing on Hortonworks also, I can share with you the virtual machine of Hortonworks as well. or you can also download, or if you want, I can also share on a Google Cloud. So this is like this is what where we will be practicing on version 1.5. However, whatever code is there on 1 can be written in 2, and most of the companies are working on version 1.6 most, and also most of the companies are working on version 1.3. So these are the different versions of Spark. If you are having any doubts, let me know. Okay. So there was something called as a Hadoop MapReduce till now, or till the year 2009. Most of the people were working into the Hadoop MapReduce programming. They were writing a complex code in Java and doing it. Then what happened is from the year 2007 until 2015, lot of tools were developed. Like in Pig was developed by Yahoo that you have already studied, or if you have missed, you will be studying soon. Hive was developed by Facebook, querying type of it. Then Uzi was a job scheduler developed by Cloudera and later on outsourced. Then there was something called as a Graph Lab. Graph Lab is nothing but a graph-based high-performance distributed computing framework. It is written in C++. Then there is something called as a Storm, but Storm is hardly used now. Some places only it is used. It is free and open source distributed real-time computing system. Then there was something called as a Mahout, Mahout, like you, the one who controls the elephant mouth. So you had something called as a mouth that was used for machine learning. You had something called as a Prigel that was used for graph processing. Similar to Prigel, Prigel is the one from Google, I believe, if not mistaken. And Giraffe is the open source counterpart to the Prigel. Okay, and so on and so forth. So what happened in from year 2007 to 2015 is there was also Impala for querying and so on. Many more tools were developed from 2017 to 2015 on top of Hadoop MapReduce. So it was like if you are going into one organization, you have to learn one thing. Then again going into another organization, you have to again learn other thing. But what happened in the year 2014 is then came the Spark. So once you come into the Spark world, you just have to forget all this thing. Even if you don't know any of this thing, it's okay. So you just have to learn Spark, and using the Spark, you can do core Spark programming. You can use Spark SQL to do a Spark SQL. You can also use Spark for streaming purpose. So you don't have to depend on so many different tools. You can just use Spark, and is the developer who is working, he can just work on Spark, and he will able to work in most of the organization. You don't have to retrain them again and again to work on different tools. So Spark was like there is only one tool. If you learn this, you know most of the things. So it is like the complete package that is available. Spark provides scheduling, monitoring, distribution, and all. Okay. So let us see how the Spark should look like. What all things are there in Spark. So let us see what all things are present in Spark language. So let us start with the programming language. So we can program into Scala using Scala programming language. I believe 50%, Python I believe 30%, Java, then R. This is mathematical, mostly used by data scientists. So there is an inner circle which shows all the programming language that you can use. You can use Scala, Python, Java, or R. So let us draw the second circle. Okay. On top of this, You can use SQL programming language, that is Spark SQL, its own SQL. You can use, I will write Spark SQL. You can use Spark Streaming for streaming real-time data. You have a Spark Machine Library language, mlib. So they have a separate library for machine learning. It's mlib. Then they have GraphX. GraphX is nothing but represent the data as a graph. That is to show the data as edges and nodes. So like this is the two nodes and this is the branch that is connecting to it. So GraphX is a graph based. Okay. Then there is something called as a tachyon. Tachyon is nothing but a file system that is similar to HDFS. You have something called as a BlinkDB, that is nothing but a query engine. So these are the different things available in the second circle, out of which we will be learning these parts. We'll be learning Spark SQL. Over here we will be learning Scala, we're learning Spark SQL, Spark streaming, and just the introduction of machine library because it is used for machine learning. Okay. So how the system can be used? So these are the different things available. One more circle. Now the Spark can be used either in a local mode. So once used in a local mode, excuse me. Okay, just mute it. Okay, so it can be used in a local mode wherein it can interact with multiple databases. So it's like it is interacting with maybe DB2, or it is interacting with MySQL databases or an Oracle database and so on. So it can be running in a local mode, and the Spark can run and it can work with different databases. It can also run in a standalone mode. Standalone mode means you have a multiple computers in cluster. Let's say around 8 computers are there in cluster, but there is no Hadoop installed. Spark has its own resource manager and that will control all the resources. So there is no Hadoop installation. On top of Hadoop, it can run. So it is again the same thing. It is having a cluster and with Hadoop installation. And over here, it will be using Yarn for resource management. And this is the most popular one. This is the most popular one, the Spark that is sitting on top of Hadoop. And there can be the original one, that is a Mesos mode. That is the original one, I can say, wherein the Mesos will be the resource manager. So these are the different ways or the different uh, modes in which Spark can be used, either in local mode or standalone, but Hadoop is not installed. Popular one is with Hadoop or the Mesos mode. What we are studying now is this one, the popular one that is on top of Hadoop. And however, if you learn one thing, the programming is still the same, only the resource management is different, which is transparent to you. Okay. And finally, the outermost circle, you can have a RDBMS BMS kind of database with which the Spark can interact. It can read the data directly from RDBMS, or it can also read from NoSQL databases. You can also use Flume. You remember we had used it for downloading the Twitter data. You can also use Kafka. Kafka will be using it in this session, meaning in this coming few weeks. You can also have your own apps built on Spark. So you will be making an application and Maybe you can share it with other people, not like a mobile app, but the Spark app that you will be using for data analysis purpose. Any doubts until now?
Hi Harish.
Yeah,
Yeah.
yeah, Muni.
Harish, there is something like Scala and Spark layer wise you have segregated, right? So basic layer, main layer will be a programming language. On top of that, what is that layer name?
Uh, sc- we are not looking into the architecture right now, but this one, like what we are seeing over here is this is the different programming language that we can use, and top of which what all applications we can use, like
Okay.
Spark Streaming, machine learning library, graphics, Tykon or BlinkDB or Spark SQL. So these are the applications. And on top of it, we are just showing what are the different modes in which we can use, either in the local mode or the standalone mode without the Hadoop, or the popular one is with using the Hadoop, or in the Mesos mode wherein the Mesos is the resource manager, the original one. And outside that, it can interact with RDBMS, NoSQL, Flume, Kafka, and you can make your own applications on it.
Okay.
Okay, any other doubts? Okay, so we'll go further. We'll go further. This Spark, the contribution is by lot many people who are contributing into the Spark. There are 500 plus companies that have contributed to Spark so far. 4,000 plus developers, and Apache commitments are received from 100 plus organizations committed to Apache Spark. So there is lot of support from other external parties as well. So many 100 plus organizations have already put their code into the Apache Spark. 500 plus companies and 4,000 plus developers have worked into it. Now let us compare this MapReduce, this Hadoop with Spark. Let us compare it with it. Okay. So in Hadoop, if you remember, there was something called as a MapReduce. There was something called as a YARN, and there was something called as a HDFS. So once you come into Spark, instead of MapReduce, you won't be using MapReduce. You will be using your own Spark or the core Spark. So you will be having doing a core Spark programming. You will be writing a program using a Scala programming language, and you will be using Spark for it. In case of Spark, you can either prefer to use Yarn itself. So you can use it Yarn if you want, or instead of Yarn, you can also use the original thing which was built over it. That is Mesos. So you can either use a Yarn over here for resource management, or you can also use Mesos. And for database, either you can use a HDFS or you can use a Tachyon. So either you can still use HDFS as well, or you can use a Tachyon. Similarly, in case of what we studied in Hive, Instead of Hive, you will be using Spark SQL. Mahout, M-A-H-O-U-T, that is machine learning thing. Here you will be having its own Spark mlib. And the Storm, instead of Storm, you are having Spark streaming. So this is how it is related, and what is the relative thing that we'll be studying now is this one. Okay. How the map radius used to work is the original data was in Hadoop HDFS system, let's say. So from HDFS system, the data will go into Hadoop MapReduce. And from Hadoop MapReduce, again, it will do some processing, again, write into Hadoop HDFS. Again, it will do MapReduce. Again, it will write into Hadoop HDFS. So what was happening is it was going and reading and writing from the memory again and again. So if you write more and more and read and write more from memory, it will actually get slow. So how Spark helps over here is, instead of HDFS, what it does is it uses RAM for it. So the data goes into RAM, then Spark does some processing, then again puts the data into RAM, and again Spark does some processing, and it will finally give the output into, let's say it is updating some database, let's say Cassandra, or maybe any database it want to update, NoSQL database or Oracle or DB2, whatever. So it has so many connectors. So what is the difference over here is it prefers to use a RAM. If the RAM is not available, then it will definitely go into memory or hard disk, and mostly the hard disk used is SSD. So solid state drive is usually very fast. So this is how it works. Like the data is not going into the memory again and again, like it was going into the memory again and a hard disk again and again, and it was very slow or bit slow. By doing this, it will be either into the RAM, and if the RAM is full, it will go into hard disk, and hard disk will be SSD, and specific size data will be memory will be allocated, and so on, making it 10 to 100 times faster than the map reduce programming. So Spark is actually 10 to 100 times more fast. That is why people are more using this Spark day in and day out, because they want the faster processing. Let's say you are using a Ola cab or a Grab cab or a Uber cab. So these people need a fast calculation of demand. How is the demand? What should be the price that should be shown? So it should be really very fast. If I'm getting a output after 5 minutes or 10 minutes, it is a long duration. That's not correct. So it should be very fast. As per the demand, the cost should increase, and as the demand goes down, the cost will decrease, and so on. So that's the reason, since Spark is so fast, it is used in most of the places. So from whom you can get the Spark? In short, who is the distributor of the Spark? And what are the different applications that are being using this thing? Different applications that are using Spark. So the major distributor of a Spark is undoubtedly Databricks, because these are the people, this is the company found by a people who actually invented the Spark. Hortonworks, Cloudera, Mapr, Oracle, IBM, SAP, Pivotal, Blue Data, and so on. Their list goes on and on. So these are the different distributors who distribute the Spark. Okay, and the Spark is used in multiple applications like Tableau, MicroStrategy, Qlik, Elasticsearch, Pentaho, and many more applications use this Spark. So these are the different applications that use Spark. Okay, and the Spark is really very fast. There is a comparison available for the Spark, how the Spark was very fast and how what was the time it took. So I will not give the much detail any of its theory, but for your understanding, it was 3 times faster than MapReduce. It was 3 times faster than MapReduce when they were sorting the 100 TB of data. 100 TB of data was sorted in 2014. So Spark was 3 times faster than MapReduce, even though it was using 10 times less machine. So even though it was using 10 times less number of machines, it was working on MapReduce was working on 2100 machines or 2100 nodes MapReduce, whereas the Spark was running on around 206 machines, and it took around 72 minutes for MapReduce to sort 100 TB of data, whereas the Spark sorted the same amount of data in approximately 23 minutes. So even though it was using 10 times less the machine, it was 3 times more faster. So this is the speed, this is the performance improvement that you achieve by moving into Spark. So that's the reason most of the companies who are newly going into big data prefer to use Spark itself. And also the companies who are already on big data and they want to increase the speed further, so they prefer to as well use this Spark or migrate from Hadoop to Spark or keep the older things on Spark, Hadoop only and develop the new codes on Spark so that it is at least faster. Okay. Any doubts until now? If no doubts,
Harish,
then
could
yeah,
could you go back to the applications using slide
yeah,
before the,
yes. So these are the applications that are using the Spark.
third one is Click, right?
Yeah.
What application or where we are using somewhere else I heard? Is it like finance or
Which one? Click one?
yeah?
Even I am not much aware of it where they are using. Actually, they are a company. The entire company is there. I think so. It is a US based company, and they are using into multiple products. Even I am not aware actually which product they are using, but I think so. It's for business intelligence. They are using it for BI. In which domain that I am not sure as well.
Okay,
Okay. So these are the different companies. They have made multiple tools using it in their respective domains. Okay. So what we'll do is the time is around 1:18 now, and we'll take a short break until 1:30 because the next topic is a big topic, that is RDD, and we cannot stop in middle, which will go at least for 30 minutes plus. So we'll take a break of 10 minutes, and the time is 1:18 or 1:19 or 1:20 Singapore time. India time should be around 10:50. Yeah, it should be around 10:50. So India time will be coming back at around after 10 minutes, and we'll continue with something new called as a RDD. Okay, so we'll take a break. Thank you.